In the past, we've already experimented with agents by creating a mafia game, but at that point of time, our agents didn't exactly talk to each other, rather than they were talking to a common room, and then we were simulating a conversation within that space. In this video, I would like to do a different experiment, and I would like to create agents which can direct their message directly to a different agent, then listen to the messages which they hear from those agents and simulate a conversation in a more sophisticated way. As in the past, we will need a large language model, and I'm going to use AWS Bedrock with Cloud model today. And we will need for the communication part some kind of a pub sub. And I'm going to use for that Voki. So without further ado, let's dive in and let's create a small prototype imitating agent communication. As in the past, let's create file agent.js, where we will keep all the main logic of our agent. It will be some kind of a class agent, which will contain a constructor, which will accept probably agent name, so that agent knows who they are. And also we will need to know to whom we are talking to. So I will put here also another agent, which will be the name of the agent to whom we will be addressing our messages. And we'll put those into internal properties. We'll also need to keep some kind of a short memory so that our agent, when talking, can relate to what they told already a second ago. For this, I will have a simple array short memory. We can do it differently later, but for now that will be sufficient. Then we'll have some kind of a start method, which we are going to call to start and initiate the conversation in our agent, which actually makes more sense to call initiate in this case. And in this call, we will need to do two things. First of all, we want to listen to other agents, whoever tells us something. So let's say we will assume that we will have some kind of a method start listening to others. And then we also would like to initiate the conversation to kind of talk to someone for the first time. And for this, we will have kind of this start conversation method, and it doesn't exist yet. And we will direct our message, let's say, to another agent. We might have multiple agents here, but having two at the start is sufficient. And finally, we will export our agent. Export default agent. And to run and test our code, we will create two agents independent from each other. So for example, run agent 1.js. And here we will have some kind of agent. And it will be new agent. Can we do something like this? Yes. And we will give some name to the agent. I'm taking just something from Zootopia because it's the first thing which comes to my mind. And it will be Judy. And then Judy will talk to Nick. If you haven't watched Zootopia, you should do so. And then we will call agent initialize, and that should start our agent. And the same for the agent number 2. But here we will have the agent whose name is Nick, and Nick is going to talk to Judy. So they kind of aware of the presence of each other. We still don't have much, but let's run this code to see that at least the basics are working. So I'll go to the terminal and I will do the node run agent, so the name of our file JS, and we got the error from a node. Cannot use import statement outside of a module because to load an AS module, set type module in the package JSON. This is because we are using ECMAScript modules, by the way, how we are importing them, and we'll need that, which I was hoping that once we will going to install some of the packages, we will add that stuff there. But let's actually initiate the package JSON right now and add those type modules to have kind of a cleaner picture. So I will do node init and or was it npm init? Yes. So we will agree to everything, and we can of course add extra information, but not really something which I wanted to do. And we will get our package.json, and here we will have some basic stuff. So here we now can type module, and that should fix the error which we have seen. So if I will run agent 1 again, it again says cannot find module. Okay, let's see. So it complains about this one. What if I will add JS over here, which is a bit silly. Okay, that was an issue. And if I will run the second one, I would also need to fix over here the JS so that we are importing the agent from agent.js. That actually doesn't do anything impressive yet. So let's improve and build upon our agent class. And let's start by listening to other agents. So when it comes to the listening and talking capabilities, we are going to rely on a pub/sub messaging pattern where we have some kind of a channel where we can publish messages on one hand, and on the other hand we can subscribe and read those messages. So now imagine each of our agents, they will have their own channel to which they will subscribe. They will be like ears of our agent, and other agents will be able to send messages to that channel so that an agent can consume those messages and then react to that, to respond, and then send back the message to the channel of the agent they are talking to. So we are keeping our agents in separate processes. They're independent entities, but they still can exchange those messages and keep up with the conversation. For a pub/sub, we can use a variety of different technologies, but today what I wanted to use is Volky. This is an open source in-memory data store, very useful for a variety of different use cases, including pub/sub. And we will need a couple of libraries to apply it, but we will come to that gradually. Let's just start by implementing a function start listening to others. I will add it over here in the agent class. And let's assume that we already have some functionality for Volky to create the channel and subscribe to that. So I will say that we have some kind of a subscriber, which we will get by implementing the function subscribe and providing the name of the channel, which will be the agent name that we already have, so that each agent again has their own ears where they're listening to the messages directed to that agent. So we will have per each agent one channel. And this we will implement in the next step. But let's assume that actually it returns some kind of a subscriber, and then we can subscribe to a message event. And when we receive that message, we can process that data that we get. And we will get there some information from a channel and some message. One of the decisions we will have to make here is about the format of the messages which are going to be exchanged across the agents. And I believe that we will need to have two properties within a message. The information itself, whatever is the body of the message which the one agent will send to another, and also the name of the agent. So assuming that one, and also the messages will be sent in kind of a string format, here we can say that we will have some kind of a parsed message, which will be JSON parse message. And within that we will have a parsed message agent and parse message. Admittedly, the namings can be really improved here, but in any case. So now with this, what we can do, we can reply to that message, the message itself, so this one, and also we will indicate some recipient to whom we want to send that message, and we're going to implement it in a second. But first, let's deal with the subscribe method and introduce Walkie into our small project and create those channels and subscribe to them and use those as a basis for our communication. For that, we will need a couple of libraries. To work with Walkie itself, we need to install IO Walkie. And also, I will install .env so that I have a convenient place to store my Walkie service credentials and later AWS credentials. For the Walkie, you can download the code and set up the service locally on your machine, or you can deploy it somewhere in the cloud. I work at Ivan, so I'm using Ivan for caching and their Walkie service, and I like Ivan platform, so totally recommended. You can follow the link in the description if you want also to have your own Walkie service from Ivan platform. It's just a couple of minutes and then you don't need to deal with all the infrastructure. And within the Walkie description page of my service, I do have this service URI, which I'm copying, and then I can, using the .NET, I will rely on the credentials which will be stored in the .env file, and I will call it just Walkie and copy that credential over here. We also have here password, and I'm going to destroy the service after I'm done, so you won't be able to copy it and use it. But this is how my connection string looks. Depending on how you deploy your Walkie and where it will be locally or in the cloud, your connection stuff might be different, so you can check the documentation and set it up accordingly. Now, to avoid polluting our agent class, I will create a separate file, which I will call helpers, can be something else, where I will put the functionality to call or to work with Walkie, for example, or to work with AWS later. It will be a salad of different things here. And the first thing which I would like to add is actually that method subscribe to a channel over here using the Walkie library. So we will need to import Walkie from Walkie, no, IO Walkie, yes, this one. And we also will need to have our .env, and we need to initialize the .env with .env config. So now we can create the Walkie client. And here we will provide the connection string to the Walkie service, which I showed before, which I have right now in the .env file. So I will put the process env and Walkie. Now we can create that subscribe method, and I'm already exporting it from this file. It will take a channel string to which we want to subscribe, and then it will subscribe it using the Walkie client. So we do the client, and then we have a subscribe method over here. We need to specify the channel, and then for some kind of errors or like to know that we successfully subscribed to the channel, we will have some callback over here. It has error object and also the count object. Count is a number of channels that client is subscribed to. And here we can output the errors or success messages if we want to. And at the end, I will return the client itself. It just so that I don't have to create the client in the agent file, because over here, the subscriber is actually the Volky client. So we could include it here in the agent, but I didn't want the agent object, the agent class, to know about Volky. So in this way, we can just use it through the helpers function and keep the Volky client only there. Let me try to add that one. So now we have a subscribe from the helpers over here. And we can move on to create a method reply to message. Now, so let's add that one. So we are going to reply to the message, and we are going to take message as a parameter and the agent, the recipient. Let's call that the recipient. Or maybe it's actually a bit more logical to switch those. So we will reply to whom first, and then what exactly we will reply there. And then I will switch them over here as well. And in this method, we are going to introduce these thinking capabilities. So we will take that message and we will ask a large language model to help us to reply to that message. So what we are going to have in short, we are going to get some kind of a prompt, to create a prompt, which we are going to send to the large language model together with the message itself. Then we are going to invoke the model with that prompt. And then we are going to receive that message and send it back to the channel of the agent to whom we are talking to. And one extra thing which I want to do here is to populate our short memory. I mean, not ours, but the agent's one. So that the agent can later relate what they actually told a second ago, and they can build that conversation based on the discussions they had before. So let's do it. For the prompts, I do want to cheat. I already prepared some prompt file which we can use so that I don't have to type all those prompts on camera. And you already probably noticed that I do tons of typos, so it's not a joy to observe. So let's create a prompt.js, prompts.js, and I will copy paste here what I have. So some of the ideas are based, actually all of the ideas are based on the project which Sebi has done, my colleague. The link to his description of the project, and he uses Java there and Quarkus, I think it's called. So check it out, especially if you're a Java developer. Sebi did amazing work on building this small world and also visualizations of different agents talking to each other and posting stuff on their own virtual Twitter analogy and doing some other crazy stuff. I took that idea from Sebi because he introduced a planet. He introduced the planet Hypola, not sure how to pronounce it. And when I experimented with large language model and trying to make it a bit more talkative, I had like a trouble that the model was not really giving me meaningful conversations or wasn't really evolving those conversations. Till actually I use this kind of imaginary place. And that actually worked pretty well because now agents, they start talking to each other. They want to grow some flowers. They want to organize some events. I don't know what is this with some imaginary places and those fantasies about them, but it works pretty well because it makes the engaging continuous conversation between two agents. So the initial prompt start is that you live on the planet Hypola. It's very cozy and small, and your name is this. And then I'm giving some instructions to the agents. If they meet another agent for the first time, they need to introduce themselves and also remember and learn their name. If they are within an ongoing conversation, they don't need to say hello each time. They just continue the conversation. And then I don't want them also to talk non-stop, so I want them at some point of time to finish that conversation. And then we have two types of prompts, one for starting the conversation and another one to continue the conversation. I kind of felt that would be nice to separate them, especially the large language models. They are super picky on the prompts, and then you don't want to keep it too long. And now looking at this code, I think I'm missing something here. I was refactoring and doing some stuff. So the get started conversation right now takes the prompt start. So you are inhabitant, your name is, and then the instructions. But what we are missing here, I believe, is to say that you are meeting this amazing person. Let me copy this and we will correct it on a go. So we have the introduction, then you are meeting another inhabitant, start the conversation. And then we are given instructions. I think that will be enough. And then the continuation is just includes also, this is a conversation so far, and then we are providing some kind of a memory string, which is our short memory. To use this in the code, we can add an extra function. Let's comment this out for a second. And I will add another function called getPrompt, which will take the message itself and then based on the state of the conversation, it will return us different types of prompts. So if this is a new conversation, so if we don't really have message yet, then it means that we are just starting the conversation. So we will return, and let me see how get started conversation prompt. And it got included here from the prompts.js. Otherwise, we will return the other prompt, get continue conversation. And we will provide the message. And what else we need there? The memory string. For the memory string, and we will talk to it about it in a second, but it will be our this short memory. We will join it with some kind of, let's say, those tabs. And what was our final property there? Oh wait, it was agent first. Instead of message, we will have here this agent name, and the message goes to the end. Then what we have, so the agent name, those are like your name is agent name. Then we provide the memory string over here, and then we provide the message and ask to respond to that message. Now we can use that getPrompt method in the reply to message call. So here we will have getPrompt, and we will put there the message which we received. It will be this getPrompt. Next, we are going to call a large language model using that prompt. So we will have some kind of a method invoke model, where we will provide the prompt, and we will create that method just in a second. Let's assume that we have it. Meanwhile, we'll update our short memory, again, not ours, but the agent short memory, with the information, with the message which we received first, and secondly, what we replied. And finally, we will send that response which we created using large language model to the channel of the corresponding agent. So we will reply to them so that they will receive that message and then can send us a new message. For this, we will need some kind of a send to channel method, which we are going to create, and will be asynchronous method most probably. So will be await send to channel, and then here we'll have the channel name, which would be the recipient, so the other agent, and then the message itself. And here again, we are going to use JSON. We are going to have two properties which we send within that message object. One is the agent name, so from whom this message comes, and this will be our name, I mean the current agent. And the second one will be the message itself, which will be the stuff which we got from the large language model. So now I guess we can implement the send to channel first because it's a bit easier than the invoke the model. So for the send to channel, let's add another method to our helpers. And send to channel will be also relying on the Volky client. So it had a channel and it has a message. And we have Volky client, and we will publish a message to the channel. We are almost done, but what we are missing is the functionality to work with the large language model. And when it comes to the models, you have a variety of different options you can choose from. You can go with an open source model and run it yourself. You can use OpenAI, as I was showing in the past video, or for diversity, I decided to go with Amazon Bedrock and the Claude model. With Amazon Bedrock, you get a variety of different options which you can select from. So I actually tried Titan, I tried Llama, and I tried Claude. Titan was nice, but it felt that it was above it to pretend to be an agent. And when I gave some ideas and asked, could you kind of pretend to be this character, it told me that it's not ChatGPT and I shouldn't expect it. Then Llama was talking a bit too much, and then I stopped with a Claude as kind of the easiest option for this experiment. Then when you go to the providers over here, you can select different options and see what is the model ID, because you need to provide it when you're using Bedrock. Also, you have the request example, which is very, very useful, because then you know what is in which format you actually need to enter that information. So for example, for Claude over here, for Anthropic, where was it? Yeah, so I used, I think I used Haiku. And then here I was relying on this model ID, and the request, it has different types of objects you need to provide. For example, here's like role user. Then you can provide this type image. I was using just text. I didn't use anything a bit more complicated. So my stuff actually looks pretty basic. So with that, of course, you need to have the key and the secret for AWS. You can check documentation if you don't know how to do it. Or if you also want me to show that, put it in the description, in the comments. I can create a short video for that. And then you either add those credentials to .env file over here, or you use a different mechanism, for example, keeping it in some other environment object, or using some other secret storage mechanism. The functionality to work with Amazon Bedrock will go to helpers.js, but before that we need to install another library. We need to install AWS SDK client Bedrock runtime. We might need something else, but let's start with this one and see if that will be enough. From this library, we will need a couple of methods. So let me add it in front. So we will import two things: Bedrock runtime client, and yes, this one, and also invoke model command. And first we will create the Bedrock client. Here we will need to provide the credentials which you store somewhere and use somehow, and it will be credentials, and the object with secret access key. We also need to specify the region where we have our Bedrock service. Depending on the region, you have different models and different versions available, so this is quite important. I'm using US East 1. And now finally we can add that invoke model function itself. It will take the prompt which we give it, and whatever properties the invoke model command expects, we can actually copy from this example which is given. Let me just grab everything. That will save us a bit of effort. And we will need to change a couple of things. So here we have the model ID itself. This depends on the model which you are using, then content type, accept, body. Here we're moving a bit closer to what we exactly want to modify. Then whatever version you have, max tokens, and the messages. So for the messages, I'm not going to use anything with the image. I just need text. And the text will be the prompt which we created in the past. And then we can take the command which we created and send it to the client. So we have the Bedrock client. We can do the send, and then we will provide that command, and we will get some kind of response from it. And we need to add async over here. Is that over here? It will be, the invoke model will be async. And for await, we will need to add async to the function definition. And then we need to process the response which we got from the Bedrock API. And it will really depend on what model you used, because the whole tree of the response object will be linked to how the model itself responded. So Titan, Claude, and Llama will have different properties, and you might need to figure out what exactly and how it goes whenever you are switching between those models. But let me show you what worked with Claude. So we will need the text decoder here, and we are going to ask it to decode the response body. And this will return us something which we can, I don't know, call decoded response body. But sadly, it's not only what we need also to parse this with JSON parse. And that it should work. We will see if we have any errors later. And finally, we will return the content of that decoded response body, and it can contain multiple items there. So we are going to take the first one because we sent only one message in the content. I am actually wondering if you have like image here, if you have several of those objects, maybe you have some multiple responses back. Not sure, don't quote me on that. But we're going to take the content, the first one, and then we are going to return the message, the text object from there. And response, why we're not using this? Because I made a typo. Cool, so this will be good to invoke the model. So we can now bring it back to our agent. We can add it to the agent. And await operator can only be used in async function. So this becomes, reply to the message becomes async. Where else we have errors? Let's try and run it, and I'm quite sure it will fail. Missing await for the async operator. Okay, so a reply to message is async, so we will do the await over here. That makes actually this one async. Then we will uncomment these ports, and I get that we also need to await for those. And it makes our initialize async Start conversation. Yes, start conversation we haven't added yet. What I had in mind is for start conversation, it just has the same method as a reply to message, but we just don't provide any message. So if I will do here start conversation, then we will have with whom we want to start the conversation, recipient, and what we are going to do, we are going to run reply to message and just provide the recipient and do not provide the message itself. That will be await, and that makes this one async. And also that would mean that in the reply to message, we need to make sure that we are not populating our short memory with an empty message. So whenever we initiate the conversation, we still not yet having any message coming. We are sending the first message. So the short memory should not have that information. So here we will just say, if there is a message, only then please send to the short memory that the recipient or whatever agent said this message. If not, populate just the second one. And that, what else we have? Void function value used. Yes, this is wrong. This should go outside. Let me see if we have anything else which is very obvious. If not, we will catch more issues when we are going to run it. Let's now run it and see tons of different things. So I will do node agent run agent 1. Let's see. Okay. The first argument must be of type string. This is totally not the most descriptive error message which I have gotten. So let me check. Let's just Google it. So after some experiments, I have figured it out. What I was missing is this JSON stringify for the body itself. So the body which we are sending there should be stringified, and now I'm getting a totally different error related to Walkie. So if I will run the agent again, then I will get an error that the connection is in subscriber mode, only subscriber commands may be used. And that's because I tried kind of to save on some lines of code, and I'm not really a Walkie specialist. So what we cannot do, we cannot have this Walkie client, which I'm using in both subscribe and then publish modes. So what I'm going to do, I will just copy it within the subscribe and duplicate for the publish. So in that case, we will have separate clients, one responsible for listening and another responsible for publishing. Still, it will be same channel because the channel is the name of the agent. But in this way, it doesn't really give me any errors, I believe. So let's run the agent 2. Successfully subscribed to Nick and now to Judy. And that will not show us anything else, but no errors is good. What I forgot to do is to add a couple of console logs so that we have some output from that conversation. So let's go somewhere over here where we're replying to a message, and let's add a console log. That will give us at least some sense of what is going on. So now, can I actually assemble somehow those next to each other? Split right, look at this, I can do that. And so that we can see it a bit more clearly, I will add the console log here and I will put some kind of breakers between the messages. And also I can do the to upper case to see what we will get. So I will run the first one and the second one next to it. So we subscribed, and then we have Judy and Nick. Let me scroll up. So Judy says, greetings. And then they start talking. Delightful to see you again. My name is undefined. Okay, I see. I see that I think I have somewhere some kind of issue with the code. And indeed, I missed it over here because it was expecting the agent name and I didn't provide it. So we can put it here, this agent name. And now I hope it will have a better effect on those conversations. Can we add also something into the prompts, like be really concise, because I'm talking too much. I will add it maybe over here as a first one. Be short. Very maybe concise. And let's try again. So Nick said hello, and then do we have? Yeah, it's kind of replies. I'm so delightful to hear that you've been enjoying this beautiful weather and tending to your lovely, whatever it is, tulips. You see, they're talking about flowers again. Thank you for the enthusiasm. Yeah, so it's not exactly short, to be honest, but I think it actually works. So whoever starts the conversation first, because I don't really start them simultaneously, so by the time the Judy sends her first message, because I started her first, Nick actually misses that one, but then Nick actually sends a message again, and then Judy replies, hello, Nick. So I'm thinking how to fix this issue that when we start the first agent immediately sends a message to the second agent, but the second agent starts a bit later just because by the nature of the how I run the code. And I mean, there can be a bit more sophisticated fixes. But what if we just determine who starts the conversation first, and then we will run that agent the second. So let's say Judy starts the conversation. So only Judy will run the start conversation, so she will initiate the conversation, but she needs to initiate it when Nick is already listening. So here I would say if this agent name is Judy, and I know it's a very dirty workaround, but it will work. So then we start the conversation. And now let's clean this up. And first let's run Nick. And Nick will be just listening because it will start listening to others and it will not go into this condition. And then we'll start the code for Judy. And Judy will say, I'm Judy. Hello, Nick. And then Nick will reply, hello, Judy. So then we don't have this conflict that kind of one agent misses the reply from the other agent, but in their memory, they actually said that phrase already. So yeah, so this is how you can simply create a conversation using a pops-up messaging pattern to interchange messages between two agents. I hope this was somehow helpful, and if you have some questions or some more ideas, please leave them in the comment section below.